Welcome to another episode of Devtool Them All. In this episode, we're going to Devtool Hacker News, a very popular website for effectively news. And it's well known for its really simple design and lightweightness. While we jump into it and show them. As usual, we're going to go to news.ycombinator.com and hit enter. And immediately we get the answer. And this is the beauty. This is what I love about this website. You know, it was designed as if it was designed in 1990s. I personally don't care about how website looks like. It gives you fast results and it gives you exactly what you need. And it uses the minimum sets of, technologies that is effectively common in the entire stack. You can literally call it from anywhere. And you wouldn't have to worry about anything. It will just work. And that's the beauty of this. Look at this. It literally fits what? This is 7 resources. That's all what it needed. It uses HTTP 1.1. I don't have complaints. You don't have to use HTTP 2, right? Especially for just this number of resources. You're just pulling 7. And I have disable cache enabled, right? Disable cache enabled. All right, that's a tongue twister. But you get one point. If it's disabled, that means if there is cache, then subsequent request in this side will not load the static stuff like the CSS, the image, and the JavaScript here. We'll go through this stuff, but we're gonna go through the first request as usual. The first request here, I don't know if you guys noticed, but the bars are back in DevTools. I think it was just a bug. Last time we devtooled Spotify, this was not there. Thank God it's back. I was just hoping it was a bug. But you can notice that we didn't get any queued. We were stalled for 0.25 milliseconds. The DNS took 16 milliseconds to effectively ask the my DNS resolver for the IP address of news.ycombinator.com, and we got the result. And then after that, we initiated the connection. It took 46 milliseconds. Again, this includes the 31 millisecond of the SSL time, which is the TLS effectively. We're going to check what kind of TLS the Hacker News uses on the backend. But this is the total time. So 46 milliseconds plus 16, roughly around what? 60. So 60 milliseconds. Very fast. That tells me that I am very, very close to whatever this thing is, right? It's probably in the West Coast here in California. You can notice that it took 20 milliseconds to actually return the content that we're going to see in a minute. This is the content. It took 20 milliseconds to get the first byte and 0.5 to download the whole thing. What did we have? It's literally just 6 kilobytes. That is how efficient this thing is, and I absolutely love it. Notice that when we downloaded this is where we turn around and make additional requests. And if the moment you see this, all of them are in parallel, right? There is some sort of stalling going on. We're gonna go through that, and that's just the result of using HTTP 1.1, because we can only send one request on a given TCP connection. So on that connection ID that we created, 50020, we effectively use that same connection to send the second request, which is what? We ask for the CSS. So if we look at the content, this is what we get back, right? This is the actual first request. It's not very pretty because there is no styling. That's the default HTML design. If we don't get anything effectively, this is what we got back. And you notice that we're using good old tables, TRs. These are my favorite. Very simple, straight to the point, gives you the results. I mean, Google still uses tables and uses all these HTML tags, so I don't have any problem with that. I love it. Simple is always good. And if you notice, all of these URLs are just basically links to some other thing. So they collect. So this included some sort of a query to the database that probably is cached and nicely placed on the place so that we receive the baked HTML page all the time. Right? And probably these static pages are updated because there's no way that a query to the database took 20 milliseconds to give me this results, right? I would expect more than that, obviously. So this is definitely cache, which is great, right? So we got this result. And to make this page a little bit prettier, they are downloading the CSS, and there's an image, and there's a JS file, right? Granted that I don't know why you would just alias these functions. This is the old jQuery, probably for compatibility reasons, right? It's just basically the same functions, just calling them, referencing them. So you don't really, and then there's some helper functions, I believe, here. It's very small JavaScript file. Okay. Followed by another image that I can't see here, another GIF, and the fav icon. So that's pretty much it. So let's go ahead and also investigate some of the first requests. What do we have? What server does those guys use? Nginx, right? That explains probably the caching they have. We also notice that we don't have any redirect or anything like that, despite we actually visiting news.ycombinator.com. That tells me that this is in the HSTS list. Probably I have visited this site before, and effectively my Chrome was updated for the fact that this site is an HTTPS site. So future request will go through HTTPS. All right, so once we have made this request, we have one connection only at this point, right? So we use that same connection to request the CSS effectively, right? And we notice that the CSS took literally 16 milliseconds. So this is just, at this point, this is just that round trip time probably to go to the server and retrieve this. This is definitely cached, right, in some sort of CDN, right? And once we get that, we also, the Chrome noticed that we need the GIF, to download the GIF. We're going to need the JavaScript. We're going to need all these GIFs, which is probably referenced in here somewhere, right? So that's how Chrome decided to, hey, we need to go ahead and download all this stuff. So we made a request to this 50020, and then we noticed that, oh, we need to make a request to the rest of the stuff. So this is where the browser actually start making decisions. Okay, was it worth to wait, right, for this connection to be freed so I can send another request, or should I spin up another one? So browser in this case decided to spin up one connection 37 and another connection 33. So it spin up total of 3 TCP connections to make this request, right? A naive implementation would have been, oh, we have 7 requests or 6 requests, let's spin up 6 TCP connections. That's probably a bad idea. You know, you want to make these requests, and only as you need spin up these TCP connections. This is all heuristics that you, as the implementer of the browser, you get to decide effectively. So now we didn't spin up the connection. We sent this request. Then we said, okay, while we wait for the 17 millisecond to come back, let's send another request to get the GIF effectively, to get the GIF back, right? So in order to get the GIF back, we had to spin up a new TCP connection, right? And here it is. We have this TCP connection, 33 milliseconds, 18 milliseconds, just the SSL time. So 33, we added a cost of 33 milliseconds just to get that. 20 milliseconds is almost the de facto now time to download the content, looks like it, right? And so yeah, we spin up another TCP connection. We lost 30 seconds, which is 30 milliseconds, which is nothing, right? What kind of TLS does Hacker News use? They're using TLS 1.2, so they are incurring the cost of 2 round trips to do the SSL negotiation. And to be honest, that is pretty fast, right? That is pretty fast for 2 round trip. Just 18 milliseconds. I am amazed that this only takes 18 milliseconds. So if you divide this by what? 2, that means it's 9 milliseconds per round trip. That's the latency between me, right, which I live in Southern California, and wherever this news, wherever Hacker News is, right? So it's pretty cool. And you might say, hey, Hussein, why don't they use the latest TLS 1.3? They don't have to be honest. If they have this good latency, they don't have to. Plus, they probably left it at 1.2 for compatibility reasons. I have no idea how many clients actually hit this news, Hacker News, because not only people browse, there must be some sort of an API that has some old Python code that hits this that doesn't understand 1.3, right? So you want the server to support 1.2 or even older ones. So let's go ahead and check. If I do SSL labs, and I did, let's go ahead and check what kind of stuff, what kind of TLS those they support, right? All right. So they also continue to support TLS 1.0 and 1.1 exactly for backward compatibility reasons. This is a long discussions in the security community, to be honest. Some people are with the disabling. I don't know, some of you might know Chrome are disabling these now, TLS 1.0, 1.1, because they are so unsecure effectively, right? The fact that your server supports that, SSL lab effectively downgrade your server to B because they support this. So there is some sort of a security, I guess, hole, if you will, right? But people don't care about this, especially like what are you gonna sniff? There is no personal information when it comes to hacker news, right? So it's fine, definitely. So they support even 1.1 or 1.0. Right? So older client, if you have a fridge from 1970, what does that mean? If you have like an old client that doesn't understand 1.2, 1.3, you can still connect with 1.0 or 1.1 effectively. And you can see that we wanted to, so here's what the browser did. It created a new connection for this, and it says, okay, let's wait. I have 3 more requests to make. Is it 3 or more? Actually, more than that. What should I do? The browser queued the request on the first connection, on the 20 connection. It queued it on this one, right? What we're doing with this? We were executing this, the CSS request. So we queued the request on this, and that's why you're seeing the stall for 60 milliseconds. We waited for 60 milliseconds. You might say, should I be waiting for 60 milliseconds or create a new connection to serve this? It's a decision. The Chrome decided, no, it's not worth creating a new TCP connection and waste resources. I know I'm a little bit nitpicking, but this is the beauty of this stuff. I love this stuff, guys, right? I love to look at all these small things, right? The technical details. It's all about that stuff, guys, right? Might be just me that I find this stuff interesting. So yeah, we queued, and then once you notice that the moment this connection was freed, immediately that request was served, and that's why you see the green light, right? Also, we made the decision, or by we I mean Chrome made the decision that, hey, you know what? I'm gonna also queue that other request on the first connection as well, right? That's probably why it didn't queue it on this connection, because it's brand new. We know it's going to take a long time. Let's queue it on the first one, which is already available. So we waited for what? 34 milliseconds. Yikesy, right? It's probably not that bad, but considering that this already is available, it's probably not a bad idea to do that, right? Versus creating a new connection. So now we queued that, and then finally, once we create a new connection. Let's take a look at this. Here, this one is interesting. First of all, we didn't even queue that request for some reason, right? This gray arrowed GIF, right? We started it right here. So Chrome kind of didn't even queue it. It just waited. It didn't stall. It didn't do anything with it. It just waited, right? And then decided to stall for 60 milliseconds. That tells me either that GIF was available from the JavaScript or the CSS, probably. I'm not sure. But decided, eventually said, you know what? I'm tired of waiting. Let me just create a new connection. And boy, that was fast. It took literally 60 milliseconds. So that I cannot explain, because 60 milliseconds for both SSL and the connection itself, that means the TCP handshake was so fast. That tells me we might have gotten either, what was it called? The zero RTT here, probably, right? Zero round trip So the first TLS handshake was done with the TCP handshake. Can you even do that in HTTP 1.1? Can you even do that? That's fascinating. That took only 60 milliseconds to create this connection. I'm just fascinated about this stuff. Really odd, right? So, or either that, or we got a TCP fast open with this one. That could explain it. Obviously, no DNS, because we better don't do DNS, because we're going to the same domain. Doesn't make sense to actually do a DNS. We just cache the fact that we did DNS right here, right? So we got here, and then eventually that connection, we got a response of that gray arrow, obviously. That took 30 milliseconds compared to whatever we're downloading. This is a lot. 30 milliseconds to download a stinking 400 bytes, right? That tells me that there could be an IO. We had to go to disk to download this stuff to get the image, actually, right? Or maybe this is just the ramification of block devices. You know, if you store things in 400 bytes, doesn't mean in the storage is actually 403 bytes. You have to actually pull a whole block, which could be 4 kilobytes. So you took the hit to store that whole thing, right? Pull 4 kilobytes just to get 400 bytes out of it. So the storage and how the file system all plays a role, right? So it doesn't mean if you have like 1 byte or 2 byte, doesn't mean that you're so efficient. You could be actually, there is a lot of wastage. It depends on what is the back end storage, what kind of block device, what kind of page size you are configuring for your file system. All matter for that. What else? The final one is basically we're downloading the actual favicon. It decided to do that last, and it queued it on the latest connection that we just opened. So total, we opened what? 1, 2, 1, 2, 3, 4 connection actually, right? It's fascinating. We never actually used that connection. If you think about it, yeah, we never used that connection. Here's some optimization that could have done. Right, the favicon, we know about the favicon since the first request. So the favicon could have been queued right after this, actually. Once we have a free connection, which is we have 20 free here, right? We have 20 was free, so we could easily queued on 20, right? 33 was busy, who cares? But 37 was free. We could have actually made this request for the favicon right here, but again, maybe it's not priority to pull that favicon, right? So again, just going through all that stuff is just fascinating. And if we click on comments, I promise this is the last thing. If I click on comments, you notice the same exact thing. Now we're actually downloading the comments, and I noticed no matter how many comments we have, there's no paging here. When you pull the comments, it actually builds the whole HTML and then returns that. So for large number of comments, I can see this file gets large, but it's not really. We wouldn't have to worry about it until we get really large. Why? Because the client and the server supports caching. Where is it? I accept gzip, deflate, and Braille. Is that how we pronounce it? Braille. Zip compression. And we as the server, Nginx supports encoded this, compressed the content with gzip, so the actual in-wire compressed is so tiny, probably, right? Obviously, we talked about attacks like a crime, right? So we talked about things like crime attack and how it can happen on HTTPS, right? These are still dangerous, right? There's no a solution to this, but people can still sniff and figure out the content based on the side attack, where they say, okay, what if we send this kind of text? Does the size of the compression get smaller or larger? Based on that, they can figure out. It's like, oh, this is what the body looks like. That's why compression, headers are not compressed in 1.1, right? The actual headers are not compressed. So this is actually, the compression is actually for the body, not the header. Headers are really not compressed in HTTP 1.1 because of this, right? Because of the crime attacks, right? And the reason is because headers actually contain sensitive information, right? So, and the side attacks can happen, and people can figure out what's in the header. So if you are actually passing sensitive information in the body, be careful of these attacks, right? Just keep that in mind. This is basically the Hacker News diff tool. I really like it. It's simple. There's nothing at all in the security. We only visit one domain. Can you compare that with Spotify? We had like what, 20, 30 domains. Again, I really like simple website, but it's just probably just me. I don't really like modern stuff. We don't have to install Bootstrap and React and million JavaScript just to do simple things like that. So we really need sometimes to evaluate what we're doing and only go to the extreme when we absolutely need it, right? Sometimes I think, bloat ourselves a lot when it comes to web technology, and it's good to go back to the basics. And if this helps, why not, right? And again, that's only my opinion. I'm gonna see you in the next one. You guys stay awesome. Goodbye.